Welcome to all. Myself, R. Vivek, Assistant Professor in Mechatronics Engineering, K.S.Rangasamy College of Technology at Tiruchendur. In this video, I am going to talk about the subject is machine design. So already I posted 3 videos. Kindly watch that videos before watching these videos. In this video, I am going to talk about the topic is connecting rod and bearings. These are all the syllabus having a fourth unit, a study of bearing, a design of bearing, sliding contact and rolling contact types, design of journal bearing, lubrication in journal bearing, design of connecting radang. So this unit briefly we are going to see two topic. First one is bearing and second one is connecting rod. So first see what is connecting rod in internal engines simply call it as IC engines are those engines in which the combustion of fuel take place inside the engine cylinder. Principal parts of an engine: a cylinder and a cylinder liner, piston ring and piston ring or guarded pin, a connecting rod with small end and big end bearing, a crankshaft and crank pin, valve gear mechanism. Next, connecting rod, a intermediate member between the piston and the connecting rod. So we are came to know connecting rod is used in IC engines. So the purpose of connecting rod is intermediate member between intermediate member between the piston and the crankshaft. So it is called as a connecting rod. It is help to connect the piston and crankshaft. It is called as a connecting rod. So this is a diagram of connecting rod. So it's a cross sectional view of the connecting rod. So here it is a small end. So small end is connected in the crankshaft area, and this is a bigger end. Bigger end is connected in a piston area. So this is the simple diagram of a connecting rod. So connecting rod, the length of the connecting rod, small l, depends upon the ratio of L by R, the radius of the crank. A smaller length will decrease the ratio L by R, increase the angularity of the connecting rod, increase the thrust of the piston against the cylinder, increase the wear of the liner. Larger length of the connecting rod will increase the ratio L by R, decreases the angularity of the connecting rod, decreases the side of thrust of the resulting wear of the cylinder, but increases the overall height of the engine. A optimized LR is used to 4 to 5 ratio. So connecting rod is a very important component in IC engines. So the optimized range of L by R is a 4 to 5 range. So next, the forces acting on the connecting rod are there are major. These are the major four forces acting on the connecting rod. So the first force, a force on the piston due to a gas pressure and inertia of the respective parts. A force due to inertia of the connecting rod or inertia bending forces. A force due to the friction of the piston ring of the piston, force due to piston bearing and the crank pin bearing. So these are the four forces acting in the connecting rod. And next, a design of a connecting rod. So this is our main topic of our this unit, design of connecting rod. So first, the dimensions of crank. So the dimensions of cross section of the connecting rod, dimensions of the crank pin at big end, the piston pin at the small end, size of the bolt for screwing the big end gap, thickness of the big end gap. So the first design is the cross section of the connecting rod, and second is crank pin at the big end. Third one is size of the bolt, and finally the fourth one is thickness of the big end gap. So these are the formula we are going to use to find out the cross section of the connecting rod. So sigma c dot a divided by 1 plus a bracket in bracket L by k xx square equal to sigma c point a divided by 1 plus a bracket of L by 2 k square of 2. So these are the formula we use to find the cross section of the connecting rod. So next one is dimension of the crank pin or a big end bearing and a piston ring or small end bearing. So these are all 1, 2, 3, 4 formulas we are going to use to find the load crank pin and load on the crank pin big end and load on the piston pin and load on the piston pin or small end bearings. So this formula is to find out the size of the bolt. So this formula we are going to use to find the size of the bolt. And next, bearing. So this is another important component of any moving element. So what is bearing means a machine element which supports another moving machine element. Permits a relative motion between contact surface a contact surface of the members while carrying the load. So lubricant to reduce frictional resistance, wear and carry away the heat generated. Lubricant separates the journal and bearing, usually a mineral oil refined from the petroleum and vegetable oils, a silicon oil greases. So these are the bearing is we are known to support another moving machine element. So these are all the main purpose of we are using the bearing. First is to reduce the frictional resistance, and the second one is the lubricant separates the journal and bearing, and usually mineral oil, refined petroleum and vegetable oil, and silicon and oil greases. Classifications of bearings, so it is based upon depending upon the direction of the load. The first one is radial bearing and the second one is thrust bearing. So first this diagram shows the radial bearing diagram. It's a side view of a radial bearing diagram, and second this is the thrust bearing. The next classification is depending upon the nature of the contact. So first one is sliding contact bearing and second one is a rolling contact bearing. The nature of the contact is sliding contact is further classified into a full journal bearing and partial journal bearing and fitted journal bearing. So this diagram shows the sliding contact bearing, and this diagram calls a rolling contact bearing. And next, the types of sliding contact bearing. So sliding action is along the circumference of circle or an arc of the circle and carrying radial loads are known as a journal or slide bearing. So this is a full journal bearing. This diagram represents the partial journal bearing, and third one fitted journal bearings. So this is the design procedure for journal bearing. The first one is Ln ratio, and second one is bearing pressure, and third one is bearing characteristics number. These are all the equations we are going to use to find out the corresponding values. And design procedure for clearance ratio and coefficient of friction. This formula going to be used, and heat generation is calculated by using this formula, and heat dissipated is calculated by using this formula. So last one there is roller bearing. So roller contact bearing, the contact between the bearing surface is rolling instead of sliding, as in the sliding contact. This diagram shows the roller bearing. So advantage of bearing, so lower starting running of friction except very high load, ability of withstand mobility, shock load, accuracy, and lower ground. These are all the advantages of bearing. And disadvantages: the more noisy, low resistance, a more initial cost, and design of the bearing housing unit. So thanks for watching. So keep learning and growing with K.S. Rangasamy College of Technology. Thank you all.